I've been talking about integration methods like integration by parts and U substitution on my channel a lot lately, but I wanted to continue that discussion by talking about integration by parts, and specifically I'm going to be showing you an example in this video of how to apply integration by parts and kind of the thought process that I go through when I think about how to choose your U and your DV as you go through an integration by parts problem. And specifically, I'm going to be talking about the thought process I go through in terms of how to choose the U and the DV as you go through an integration by parts problem. Now, this clip came from one of my weekly live streams that I did recently, which I'm doing every Monday night at 5 o'clock Pacific, and I thought you'd find it pretty helpful. So I wanted to just kind of go over that and make its own video about that. And this is actually one of the formulas on my integral calculus cheat sheet or my calculus 2 study guide. If you want to check that out, there is a link down in the description below. But without further ado, let's go ahead and jump on into the example and we'll go over some integration by parts. We're going to take the integral of p to the fifth times natural log, or ln, of p dp. So I've already kind of mentioned that we're going to be going over integration by parts. Just real quickly to touch on kind of how you know that it's integration by parts, we pretty clearly have here the product of two different functions that we're integrating. That is typically going to be a pretty good sign that integration by parts would be a good option, or certainly at least considering using that to integrate whatever function you're dealing with. So since we have this product of two different functions, p to the fifth being one function and natural log of p being our other function, pretty good indication that integration by parts may be the best option. It may not, depends on what the function is, depends on the situation. There definitely are products like this where U substitution is the best option, but in this case, I think that integration by parts is going to be your best option. Where I did get this problem from, it did actually come from, the context was integration by parts. So in this case, that kind of gave it away. But, if you wanted to think about how we know integration by parts is actually going to be the best option, just kind of where my brain goes when I look at this problem specifically, obviously the product is a big key. You need that in order to use integration by parts. But what makes me think that using integration by parts is going to work quite nicely in this case is the fact that one of those products, or one of those things that is a part of the product, is just natural log of our variable. The reason why I say that is, what is the derivative of natural log of p? Well, if we took the derivative of ln p, took the derivative of that would just give us 1 over p, which if we were to think about taking the integral of p to the fifth, that would give us some sort of p to the sixth term, right? Which if we have a p to the sixth times a 1 over p, that's going to end up simplifying quite nicely. And I'll show you kind of what I mean by that. But the point is just thinking about the derivative of one of our terms with the antiderivative of the other term being p to the sixth and 1 over p. If you multiply those together, which is what the integration by parts formula is going to get us to do, things should simplify quite nicely. So let's just start with the integration by parts formula first of all. Like I said, this formula is on my Calculus 2 study guide. So if you want to go grab that, there is a link down in the description where you can get more info on that. But integration by parts, the formula says that if we have the integral of u times dv, we can rewrite that as u times v minus the integral of v times du. You can see that basically what we have in our original integral is these two things, where we are kind of converting this into another integral, which the idea is that this integral should be easier to solve than this one. But where this integral comes from is it's going to be the product of the derivative of u, du is the derivative of u, and v is the antiderivative of dv. So basically, if you take the derivative of one of your terms and the integral of the other term, the product of those two things is going to be your new integral. So just kind of looking ahead a little bit, the integral of p to the fifth being some constant times p to the sixth, multiplying that by the derivative of ln p, which is 1 over p, those are going to simplify down into just a p to the fifth term, which should be pretty easy to integrate. We can do that just using the power rule. So let's see how this actually plays out. I did just want to kind of give you a hint of, kind of when I look at a problem, you want to kind of try and think a couple steps ahead. Kind of like chess in that way. You want to think a little bit ahead just to kind of see where the problem may be going. And of course, you don't have to be able to like solve everything in your head. That's not the point. The point is just to think a little bit ahead, just to see if one method is going to actually be helpful, or at least has a chance of being helpful, or if there's another method that you might want to consider instead. Of course, sometimes with math, unfortunately, you have to just kind of experiment, go down one path or another path, and get to a dead end and realize that path doesn't work. Kind of sucks, and it kind of feels like a waste of time, but that's kind of part of that learning process. And as you start to do that more and more, you'll start to kind of recognize ahead of time in the future, I did a problem that looked kind of like this yesterday or something, and it got me to this dead end, so maybe I should try something else instead. And that's just kind of part of the process of learning math. But anyway, in this case, we have, with any integration by parts problem, the first thing you want to do is decide what's going to be your u and what's going to be your dv. So like I said, u is going to be the thing that we are going to take the derivative of. With ln p, the derivative of ln p is 1 over p. The derivative of ln of something is much, much simpler to deal with than the antiderivative of ln p, or ln of whatever our variable is. So generally, if you have natural log of your variable being one of your terms in an integration by parts problem, you probably want to take its derivative and make it u. Not necessarily always. You want to kind of consider what are your two options. Is the other one even harder to take the integral of? But if we look at our other term, in this case, p to the fifth, that's going to use power rule either way, whether we take the derivative or the integral of it. So in that case, it's actually not going to matter. P to the fifth is not going to be easier or harder if we make it dv or u. However, ln of p is going to be much easier to put as our u than it would be to put as our dv. Because what we also need to do, once we've kind of determined what our u and our dv are, is then figure out du and v. Well, like I said, du is just the derivative of u. The derivative of ln p is 1 over p, like I said. And v is always just going to be the antiderivative of whatever we said our dv is. So in this case, dv is p to the fifth. V is going to be the antiderivative of p to the fifth, which can be found using the power rule. Power rule just says we're going to raise our power by 1, so increase our power from 5 to 6, and then divide by our new power. Instead of dividing by 6, I'm instead going to multiply by 1/6. It's the exact same thing, just kind of is going to make things a little bit easier for us in the next step. And that's just another example of what I was saying earlier about just kind of having experience working through problems, being able to think ahead a little bit more. So let's go ahead and apply this formula over here now. So what we know is we had this original integral, which we could think of as u times dv. And we can now, after we've kind of figured out our u, dv, du, and v, we can use these four pieces and plug it into this formula to figure out what this original integral is equal to. And it should be equal to u times v, so ln of p times 1/6 p to the 6. I'm actually going to write it in the other order. So 1/6 p to the 6 times ln of p minus the integral of v times du. So minus the integral of 1/6 p to the 6 times du, which is 1 over p. And this is what I was getting at earlier about the derivative of ln p conveniently simplifying down with the antiderivative of p to the fifth, because now we have a p to the 6 times 1 over p. Well, this p is going to cancel with one of these p's, just turning it into the integral of 1/6 p to the fifth. So now this thing that we're integrating is something that can be integrated just using the power rule, instead of what we had before that could not just be done with the power rule. It required some additional tricks. Okay, so now what we've done is we've kind of simplified our original integral down into something else that just involves this simpler integral. And do keep in mind, we do want to still have a dp here. In fact, if you want to be kind of technically correct, we should have had a dp here and here as well. You will always put your dp, or whatever you had here, in this case it's dp, is going to go with our dv and our du. And then as a result, it ends up carrying into here as well. So now all we have to do, first of all, actually, let's think about this. We have this constant here. A constant, when you have a constant times a bunch of other stuff in an integral, the constant can be pulled out of the integral. So we can actually rewrite this as 1/6 times the integral of p to the 5th times dp, or not times dp, p to the 5th dp. And then over here, we'll still have all this stuff outside of the integral. So the nice stuff about all this stuff out here, it's already been integrated and dealt with. We still just have this integral here to deal with. So basically that's just going to carry on down. And then to integrate p to the 5th, we again just have to apply power rule, which is just going to raise our power by 1. So raise the p to the 6th, and then divide by our new power, which is the same as multiplying by 1 over that new power. So then this is going to simplify down into 1/6 p to the 6 ln of p minus 1 over 36 p to the 6. And we could simplify this a bit by pulling out a 1/6 p to the 6, because both terms have a 1/6 in common here that we could factor out, and they both have a p to the 6 here that we could factor out. Doing that is just going to give us 1/6 p to the 6, and then parentheses ln p minus 1/6. And now that's going to be, and then actually we do want to add a plus c on there as well. And then that's going to be the integral of the original function that we had to find the integral of. Well, I hope you found that video helpful. If you did, please be sure to hit that like button down below and subscribe to my channel while you're down there too. Be sure to hit that bell icon so you're notified of all my new videos and when I'm going live. Hopefully I'll see you there next Monday night and we can go over whatever questions you have live and keep learning more calculus together. Anyway, hope to see you there. Thanks and see you next time.